Hello everyone, my name is Tom Eveler and I'm with Momentive Performance Materials. And the title of the presentation today is a fully customizable viscoelastic damping layers from -54C to 204C using silicone. With that, my picture in the bottom right corner will go away and I'll come back to talk to you at the end, but I wanted to leave it out to avoid any distractions. So let's get started. At the top of the presentation, you will see 10 boxes. The box that is highlighted in blue represents which section we are currently on. I figured that should help us all follow along. So with that, we are going to play a quick video to explain what damping is. Once in the video, the sample on the left is undamped, and the sample on the right is coated with silicone on the backside. So now moving along from the damping to the evolution blue box there. And by evolution, we mean evolution of silicone for sound damping. And historically, silicone has been used in the damping space for really 4 unique properties. And in this presentation, they're going to be labeled as A, B, C, and D. So starting with A being silicone has damping properties plus added benefits. And we'll go on and explain what those added benefits are later in the presentation. B, it has great damping for high and low temperatures where other options tend to fail. C, silicone has damping for wide temperature ranges, much wider peaks as compared to the other options. And D, the most recent discovery, is the ability to customize for your specific application. So again, just to highlight, these are the 4 reasons why someone would choose a silicone for damping in the past, and these unique properties have been discovered over time. And now moving on to the application section. When I reference using silicone as a damping layer, there are really 2 formats that come to mind, both an unconstrained layer and a constrained layer. So you can see here on the left side is an example of an unconstrained layer, where you basically have a viscoelastic material, the green layer, on top of another substrate such as sheet metal. And then the constrained layer, meaning what we call here a sandwich construction, where the viscoelastic silicone is in between 2 other materials. Again, sheet metal or silicone rubber or foil would be some examples. And in terms of silicone products for constrained layer damping, we're really specifically discussing 3 forms: tapes, transfer films or free films, and contact adhesives. And typically when you get to a point of use, a silicone tape, transfer film, or contact adhesive is already cured. And therefore maintaining its viscoelastic state, which happens to be strong for damping properties, can be easily managed. Just want to touch on what a transfer film free film is. I think everybody knows what a tape and a contact adhesive is already. But what that is when you have the cured silicone, in our case, in between 2 release liners. So how this would work is you would remove an easy side release liner, apply the silicone with the other side of the release liner to an object such as the sheet metal example. Then you would remove the other release liner and maybe apply it to the sandwich construction. So sometimes it's just as important to kind of explain what your application is not as opposed to what it is. So in this technical presentation, just to summarize, we'll be focusing on using silicone in tape, transfer film, or contact adhesive format for damping purposes. Moving on from application to markets. Technology is moving fast in popular markets that rely on NVH solutions. So we really want to focus on 3 examples today. The first one being automotive. Lots of mega trends in this space now. Electrical vehicles and lightweighting being 2 examples. Second space would be electronics, which has always been and always will be a fast-moving industry. Some examples here are, let's talk cell phones. They're doing more, they're getting smaller, they're running hotter, so that may require some more higher temp damping spaces. And the last one is aerospace. And again, most recent developments, there's reusable rockets, there's more and more satellites going into space, planet exploration and space tourism, just to name a few examples where some new NVH damping solutions may be needed. So you might say to yourself, well, I've never used silicone for NVH in the past, but with these new technological advancements, there presents a lot of new challenges. So maybe it's time for new NVH solutions as well. So with our markets defined, let's go back to the 4 unique benefits of silicone as a damping product. So if you remember, we had A, B, C, and D, and of course A was first for silicone's added benefits. And we're just going to kind of touch on some of these. There are also very common added benefits of using silicone in other formats as well. So the first one being stability in harsh environments. Second being chemical, moisture, and UV resistant. Third, to excellent adhesion, including the low surface energy materials, an example being a silicone rubber. Fourth is good electrical insulation properties. And fifth is high oxygen permeability. So quick example how this would translate to the NVH space. Let's say you needed some damping properties plus your product was going to be outside. Then silicone would be a strong candidate for you. All right, moving on to letter B, high-low. So the second unique benefit of silicone for damping is high and low properties. And I'm sure most people are familiar with this graph or chart here, but just to quickly explain, the y-axis is damping performance, and the higher the peak, the better the damping performance. The x-axis being a temperature scale. So here with these dotted lines you see are kind of represent other popular viscoelastic materials to choose from. Examples could include a rubber or acrylic. Most of the time they hover around room temperatures. When silicone was tested for the NVH space, it was realized that silicone tends to work where other options fail, and these include the low temperature range and the high temperature range. So again, one example being moon boots. Again, not NVH related, but the first moon landing, they needed something that could withstand these high temperature changes from minus 280 F all the way up to 260 F. And those first moon boots were made of silicone. Moving on to letter C, which is wide ranges. The third unique benefit of silicone for damping is wide operating ranges. So same X and Y axis as before, and while testing the product for those hot and cold temperatures, it was realized that the peaks were much wider than other alternatives. So you can see how wide these orange lines are compared to how wide these green lines are on the incumbent products. This leads to a more efficient end-use product, and it could also lead to other benefits, such as a SKU consolidation by the manufacturer. As in that quick example, this one product could take the place of these 4 products. Moving on to letter D, which is customized. So the fourth unique benefit of silicone for damping is it can be customized for a specific application. And letter D represents some emerging discoveries in this space. And you may ask yourself, why is the ability to customize so important? And the first reason is NVH engineers play in a very competitive markets. We went over this on our market slide, but auto, electronics, and aerospace, there tends to be a very high reluctance to share information. Second reason is every application is different. So the ability to kind of tweak your formula is crucial. And the third one is when a lot of people look to test NVH products, they're still kind of in a discovery mode. So maybe the solution they need now, it will not be the same when they get closer to product launch. And the ability to, again, tweak that product along the way will be very beneficial. So what if, what the thought process is, what if you could take a kit and with some simple instructions, the end user could simply shift the glass transition of the product. And by doing this, they can shift the damping properties. And this was what was discovered with silicone in a kit form that could be easily done. So this chart here shows some of the peak damping temperatures that are able to be achieved with silicone in the tape, transfer film, and contact adhesive format. So you can see here on this chart, just by formulating differently with a kit, I mean, you can go to something with a specific TG of less than -50C all the way up to over 150C, and kind of dial that in as your application needs adjust. So now moving on to data, and with the 4 unique benefits of using silicone for damping identified, how can we really trust this data that you've seen on these previous slides? And the data that we have shared has been tested in 3 ways. The first, using DMA, dynamic mechanical analysis. And we ran samples of different silicone formulations, and we've actually made a chart now in Excel that you can simply type in your target peak temperature, and it'll spit out a formula that corresponds to where you're trying to dampen. The second is through Oberst beam testing with some validation partners within the NVH space, and this is a temperature and frequency sweep to validate our DMA work. And the third is through partner validation. Again, we talked that every application is different, and lots of industries have their own specific damping testing. So we worked with some people in this space, and they were able to validate the Oberst and DMA data. So we feel we're on the right track with the information shared today. Hello everyone, I'm back to wrap things up. I hope you've enjoyed the presentation so far. So in summary, 4 reasons why using silicone as a damping product. First one being the NVH plus, right? You get NVH properties plus resistance to water, solvent, UV light, and weatherability, common traits of silicone in general. Second reason is damping performance between -54C to 204C. So both those low ends and high ends there. Third unique property, wider damping ranges as compared to other NVH alternatives in the marketplace. And last, in the most recent development, ability to easily customize for your specific application. So with that, I wanted to thank my colleagues at Momentum Performance Materials and the SAE NVH Show. If you have any questions or comments, my contact information is on the screen. I'd be happy to assist you. Thank you and have a good day.